Alright guys, welcome to chapter 5. We are going to start our talk about exponents with zero and negative exponents. Hopefully when you did the Solve It on the Pearson module, you reviewed your exponents, both positive and negative, and remembered that one of the special things about exponents is that zero exponents are always going to equal 1. So for any non-zero number, when you take it to the 0 power, that then equals 1. And that is tricky for people because they'll think it's going to equal to 0 or something weird like that, but no, it is in fact equal to 1. So then, when we have negative exponents essentially flip the base. So 7 becomes 1/7, it's reciprocal, and the exponent becomes positive in the denominator. So that negative flips our base, and then the power goes in the denominator. Now, same thing happens to a negative number taken to a negative power, but that negative number is what goes down to the denominator, and that then takes whatever power it was. So if it's even, then this whole thing will obviously become positive. That's right, because any even power to an odd number makes it positive. Or any even power to a negative number makes it positive. Sorry about that. And then you can't take 0 to a power because 0 is always 0. No matter how many zeros you have multiplied, it's always going to be 0. Alright, so go ahead if you work through the Pearson module for problem 1. Then when you come to the got it, you want to try these on your own before checking your answer. So pause the video and try these. Your first one here, because the exponent is negative, it flips the base. So the base becomes 1/4. The exponent goes into the base and becomes positive 3, which then gives us 1/64, which that is as far as we can go. Moving on to B, we see that it's a value to a 0 exponent, and any number to a 0 exponent then is 1. Now coming to this negative exponent, you should immediately think, let's flip it and put the exponent on the bottom, so that becomes 1/9. Because this is just to the -1, this really flips the base, becomes 1/6 to the first power, which is just 1/6. And then our final question here, -4 to the -2nd power. So we will flip our base, so now it's 1/-4 to the 2nd power. Because think about it, this -4 is really just -4/1. And now -4 squared, because it's negative, a negative times a negative is always a positive. You cannot trust your calculator in this situation, because if you type into your calculator just -4 squared, it does the negative of 4 squared. And 4 squared is 16, so it spits out -16, which is wrong. So be careful with your calculator and powers. If you put it in there with parentheses, then it will do it right. You just have to be careful with your formatting. Go ahead and try the other couple practice problems down here. Pause the video, and then I will be back to help. Alright, so one thing you have to remember is that exponents happen first before any division. So this exponent of 2 to the 0 has to happen first, which then makes that just 1, which makes this whole thing 1. Now over here, what you need to remember is that you should never try to manually take a decimal to an exponent. So we should think of this as 3/2 to the -2, which then, because it's -2, it tells the base to flip, so that actually becomes 2/3 squared. And when a fraction is squared, it actually squares the top and the bottom. So the top squared becomes 4, the bottom squared becomes 9. So you get 4/9, which as a decimal, if you remember your rules about division of integers, 4 divided by 9, the 9 on bottom tells me whatever's on top repeats, so it'd just be 0.4 repeating. So like it says up here, an algebraic expression is simplest when powers with a variable base are written only in positive exponents. So our negative exponents, we like to first do what we can to turn them into positives. So if this base of x is really x/1, this becomes 1/x to the 9th. So if this here is 1 over n to the negative 3, what do you think is going to happen here? That's right, it still does tell us to flip the whole thing, and this becomes n to the third. You can think of it being over 1, but that doesn't matter. It's kind of irrelevant at this point. If you haven't tried C and D, give the video a pause and go ahead. But if we dive into C, this is 4. It flips the base, which C is the only thing being acted on by the negative 3. So now it's 1 over C. The C is on the denominator. And then B, well now since this is all straight multiplication, we can say it's 4 times B all over C to the third. Here, the A to the negative third, the A is the only thing with the negative power happening. So it flips this, but the 2 actually stays where it is because it's not being affected by the exponent. So 2 is still on top of 1, and now A comes back on top with the third power. So really we can just write it as 2 times A to the third power. So like it says right up top here, when we evaluate an exponential expression, we want to simplify the expression before we substitute any values. So our expression down here involves a negative exponent, so we know that that needs to have something done with it. So the w to the 0, well that actually, we could go ahead and say anything to the 0 is going to be 1, but we might as well wait and say when w goes in as 5. But the end of the negative 4 right now should go in the denominator, so w to the 0 is on top, and now is positive 4. So now we can substitute in w is actually 5, so it's 5 to the 0, and n is negative 2. So we substitute for the n, instead of writing the n again. Negative 2 to the fourth. Well, this is an even power, so I can go ahead and forget about the negative, and 2 to the fourth is just 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, so we get 1/16. If you have not tried B on your own yet, give it a shot. The n to the negative 1 on top, well remember, everything is always times a 1, because that does not change anything. So that negative 1 tells me to take that to the denominator. So this actually now becomes just 1 on top, n on bottom with a first power, which we don't really need to write. W on bottom squared. Now I can substitute in. So now it's 1 over n is negative 2, and w is a positive 5, but w also has to be squared. So now that becomes 1 over negative 2 times 5 squared gave us 25. And that gives me 1 over negative 50. And I could just rewrite that as a negative 1/50. Go ahead and try the next couple problems. Pause the video and go for those on your own. Hopefully for C, this is what you figured out. When I plug in negative 2 for n, I have negative 2 to the 0, which gives me 1. When I plug in 5 for w, I have 5 to the 6, which gives me 15,625. That is a very small fraction. If you have not tried D on your own, do so now. Alright, and then here, because w has the negative 1 exponent, that actually tells it to go up on top, so we end up with w over top of n. We substitute in 5 for w and negative 2 for n, giving me negative 5 halves, which I could simplify to negative 2.5. When approaching a problem like this, I always like to highlight all the important information first. So go ahead and check out this problem, try it on your own if you can, and think to yourself, when is w equal to 0 such that we can have w equal to negative 2? How could we have w, which is weeks, equal to negative 2? So pause this and try. Hopefully what you thought about was w equaling negative 2 is 2 weeks before the population was measured. So to deal with that, I would look at 3 to the negative 2, which would actually tell me to do 1 over 3 squared, which is actually 1/9, which means that the population 2 weeks before it was measured was 1/9 what it actually was, which makes sense if it's tripling every week. Which then gives us that this population 2 weeks ago was only 600 mosquitoes. So then W being 0, well, that would mean that this 3 times W, since W is 0, would then be 1. So 5,400 times 1 would just be 5,400 mosquitoes. So that would be my second reading. And my third, where W is equal to 1, well, that just means that 3 times 1 is 1, so it would just be 5,400 times 3, or triple the population. This gives me 16,200 mosquitoes, which gets pretty out of hand pretty fast if you don't take care of the situation. That is pretty much all I have for you on exponents, positive and or negative and zero exponents. So make sure that you've worked through the entire Pearson module. Do the practice till you're confident, and let me know if you have issues. Thank you, and have a wonderful day.